Hello, my name is Magnus Jansson and I work with market communication at Westermo. It is I that have been sending you a few emails regarding this webinar, and I hope that you will find today's topic interesting and informative and hopefully inspired to new insights and learnings. Before I hand over to the presenters, I just want to briefly tell you about Westermo. I have had some requests from both customers and colleagues out there to offer short information sessions on various topics, and this is the first attempt to an open webinar. So we have been in the business since 1975, and as a manufacturer of industrial data communication devices and software, we have gained a lot of knowledge within the company. And this is an attempt of getting some of that knowledge out there to you. We develop and manufacture all our products in our facilities in Sweden, and we have our own sales and support offices in 12 different countries. We also work with distribution partners all around the world, as we know the importance of local presence for many of our customers. So today's topic is regarding copper cables and the communication technologies that can be used in many cases instead of installing new fiber cables. And this is something that can lead to significant costs and time savings, as reusing old or existing cables will remove the need to install new cables. And to present this topic, you will have Bo Jansson, who is product manager for the Wolverine products, which is the core in our SHDSL offer. Bo has many years experience from developing products for industrial applications. And Bo's wingman will be Mikael Lindahl, who is a network application expert and part of the Westermo Network Applications team, which main responsibilities to help customers and companies to find the best and most ideal network solutions. Mikael has tons of experience from the field, working very close with customers inside their operations, which have given him real hands-on experience from many different industries. Before I hand over the presentation to Bo and Mikael, there is just one housekeeping information I'd like to give to you. If you have any questions during the webinar, please use the chat window and post your question to host. I will then gather all the questions and read it to Bo and Mikael at the end of the presentation. So please type any questions in the chat window and make sure it's addressed to host. And with that, I'd like to hand over to Bo and Mikael.
Thank you very much, Magnus. And we will now share my screen so you can see some slides and also some other information that we will give you. As Magnus mentioned, copper cables as an alternative to fiber, that is today's topic. And why does this not work? No. As an introduction, I have used this sales case. It's an installation from Denmark on a bridge, Stora Belt Bridge. This is a very long bridge. It's almost 7 kilometers long. And in the past, we had equipment installed there as well, multi-drop modems connecting IP telephony, emergency phones. There was a need to upgrade the complete system to IP. And from the beginning, they then thought about installing new fiber optical cables and fiber optical switches in order to connect to the new emergency phones. Our sales force in Denmark then contacted the company and explained that there is an option here, and that is to use SHDSL instead, and to reuse the existing cables. In our portfolio, we have one product called DDW225 that does the work. That means you can reuse the old copper cables and still achieve connectivity with IP. So IP-based communication can be achieved. With the new technology that they then installed, they also had increased bandwidth compared to what they have had before from the multi-drop modems. So it was a huge success, and this is exactly what this webinar is all about, looking at different options. And what we will do is to look at the cable alternatives, fiber versus twisted pair. If we start to look at the fiber options that they from the beginning thought about, there's a lot of advantages with fiber. You can run up to 120 kilometers, for instance. We have transceivers for that. The fiber interface itself is very secure. It's not sensitive to lightning at all, so it's lightning protected. It has very low attenuation, and that then leads to long distance. Another very good thing with fiber is high bandwidth, so you can run different applications at the same time. But there is also some minuses, and for instance, expensive contacting. That is one thing. You have to have the knowledge about contacting, and therefore it's also a demanding installation. And one very important thing is that you have to be really careful about handling a fiber optical cable. Dust sensitive or dirt will damage the connection, and that is actually the most common problem we see from support when handling fiber. So if that was a little bit background to the fiber option, we will then go into the final solution that was proposed. And this was to reuse the existing copper cables, the twisted pair that was already installed. With SHDSL, you can run up to 15 kilometers. And if we look at the application here, each emergency phone was installed 500 meters from each other, so the distance was no issue. We could achieve everything that they needed. So the existing cables could be used. It was low cost since everything was already in place. Simple installation. The only thing you need is a screwdriver to connect the units. On the minus side, if we compare fiber and copper pair, low bandwidth is something that you need to be aware of. But in this case, the emergency phones and also some CCTV installations on the bridge, the bandwidth was good enough for that installation. So that was no issue at all. Another thing when it comes to cable installations, outdoor cable installation, is that you have to be aware of lightning. It is sensitive to surge and lightning, but there are solutions for that as well, and we will cover that later on in this session.
Bo, do we have any kind of estimation of what kind of money they save on going with the existing cables comparing to fiber?
We have tried to calculate that. Of course, I have to say that we are not an installer company, but if we look at the cost for fiber cable, it's something like €1 per meter. The distance of the bridge is 7,000 meters, and the total installation was approximately 10 kilometers. So the total cost for the fiber itself was something like €10,000, and on top of that you have to calculate the installation costs, the cost for connecting all the equipment. So it is at least double the cost as for the fiber itself, and that should then be compared to the existing cable that was already installed. So they saved quite a lot of money just because of this new solution. Good. Let's move forward. And Mikael, can you talk a little bit about the technology itself?
Yeah, absolutely. SHDSL stands for Single Pair High-Speed Digital Subscriber Line, and just as the name implies, it's only a single pair that's needed to actually achieve full duplex communication over an SHDSL link. SHDSL is part of the DSL family, also with the ADSL, VDSL, so it's those kind of standard technologies. It's also standardized to an ITU-T standard, G.991.2. This standard is available on the web, so if you want to read more exact details regarding this, you can download that. But the really good thing with SHDSL is that it's actually symmetric in the speed that you can achieve on the link. So if you achieve 10 megabits on the SHDSL link, then you will have that in both directions. So compared to ADSL, for instance, where you have a higher download speed and a lower upload speed, which makes it kind of difficult to build industrial network solutions. So it's really good to have the symmetric characteristics of SHDSL in this case. The line speed can be up to 30.6 megabit per second, and that is using bonding, which is basically using both SHDSL interfaces that we have on all our managed devices and kind of aggregate them together to achieve the double speed. So the normal highest speed for a single port is 15.3 megabits per second. You can achieve distances up to 15 kilometers, and that is almost 9 or 9.3 miles. And what you also need to be aware of is that the distance and the speed are tightly dependent of each other. So the longer distance you have, the lower the speed will be. So you cannot expect to get 30 megabits per second on a 15-kilometer line. But if you have shorter distances, the speed will increase. It's a point-to-point communication. So basically, you have two devices in each end of the link. You cannot, from an SHDSL interface, build a star topology, so you attach one single interface to several other directly. That's not possible, but you can still use Ethernet to build those type of topologies. But you need to know that SHDSL is point-to-point in its characteristics. It is also completely transparent for Ethernet protocols and upper layer IP protocols, so you can send basically anything over these links.
Can you explain a little bit more about transparency, because I think that is really important.
Yeah, absolutely. Normally in industrial networks, you will have more important information that you want to make sure it receives in the other end. So often you use like VLANs to make these prioritization decisions on the network. And by using the VLAN ID, then you can prioritize certain traffic. And the good thing with SHDSL is that the VLAN tag will be forwarded intact over this link, so you will be able to receive the same information in the other end as well. So this is makes it possible to actually prioritize traffic over these links as well.
Good.
Like I said, SHDSL is a point-to-point connection, so you will have a CO device or a responder or a server if you want to in one end, and you have a CPE device in the other end, which is the initiator or the client in this case. On all our managed SHDSL devices, we have two SHDSL interfaces, and one of them are by default configured as a CO, and the other one is by default configured as a CPE. So if you connect port 1 to port 2 throughout your network, you will be able to achieve SHDSL links without having to basically do any configuration. So it's more or less a plug-and-play connection for this type of traffic. The speed is kind of dependent on the characteristics of the link. So based on how much background noise you have on the cable, it will adapt the speed accordingly. So the signal to noise ratio is the entity that controls how fast you will be able to run your communication on the line. And the signal to noise ratio is also the margin between the signal and the background noise that you have. And the bigger the margin is, the better or more stable communication you will have.
Good. If that was some details about SHDSL, I will then talk a little bit about things to consider when it comes to installation. First of all, you have to strive to always use twisted pair to avoid crosstalk. Twisted pair is a part of the standard when it refers to SHDSL, so use that, and that will be the best solution for the installation. If you have a twisted pair, the two cables will then act as one, and if you have interference from any signal, that will be then sourced onto the two pairs at the same time, because this pair is balanced. When it comes to recommendations of cables, we say that at least 0.3 square millimeter is what you should use, and this is the type of cables that are normally used in installation. So there's a lot of these type of cables already installed in communication equipment with old modems and such applications. If an external surge or lightning protector will be used, make sure that they have the right characteristics, so you can use them together with our equipment.
But how can you really tell which type of lightning protectors you should have for SHDSL?
There's some things to consider, and we will get back to some recommendations later on in this section. But what I can say is that the voltage levels from the SHDSL have to match the lightning protectors. So these are the things that you have to consider when order lightning protectors, external lightning protectors. If I then look at some other options, in some legacy solutions, there are cables designed to carry out simple switch DC. So in these types of cables, there was no need for twisted pair. The question is then, will it be possible to use these types of cables? And the answer to that is that these lines will be prone to pick up more electrical noise than a twisted pair, and that is due to that these are this is an unbalanced cable, so it's not optimized for communication. But from what we have seen over the years, this cable may work, but it needs to be tested. We also know that data rate and reach will be reduced. So using these cables, you have to test the cable carefully. And this is something that we will talk about now. So, Mikael, can you give some information about that?
Absolutely. So it's more or less impossible to know beforehand exactly what you will be able to achieve on a certain cable. So the easiest way to make sure that it will work on a certain cable is to use two devices, connect them to the cable, and measure the SNR value on the link itself. Because there are not just a cable that kind of have a role in this communication. Also, background noise and noise from other things that affects the cable itself will play a role in this, to how fast you can go and how far you can reach. When you test it, it's better to test the different pairs. If you use a multi-core, you get different characteristics depending on which pairs you are actually tested on. So if you have multiple possibilities, then please test more than one of them. Also, it's very good to do a long-term test, because you might have situations where there are external sources that causes interference on the cable. For instance, you have a huge engine that starts a few times a day, then you need to make sure that you have these events also in the testing cycle. Or if you have in a trackside application, for instance, you have different types of trains going down the tracks on this section of the railway, and then it could be good to make sure that you cover all these different types of trains that are present. And also try to use pairs that are the furthest away from other types of communications in the same cable, because it will minimize the risk of crosstalk interference from the other communications as well. If you're using shielded cables, then it's very important that you only connect the shield to the ground in one end of the cable.
One thing that you forgot to highlight is that after a test you have to use the same pair at the installation, because this is what we have tested upon. So that is also important.
Yeah.
You mentioned that you needed to install earth on one end. Why is that?
Well, if you have, in this case, SHDSL, you have usually long distances. You may be communicating between different buildings, and you will most certainly have different ground potentials in these two locations. So if you connect it to the earth in both ends, the ground potential will start to try to even out the different potentiality of this link. So that means that you can get a current moving back and forward in this shield of the cable, and that can actually affect the communication in very different and strange ways. So to make sure that you have a trouble-free communication, only connected to the ground in one end.
Mm-hmm. Yeah, that is really important.
Yeah.
Good. Mikael talked about securing the connection, and how can we then measure the SNR value? And we have some options. The first one is the easiest one, and that is to use one of our products. We have, for instance, DDW 142 or 242. Those units have LED indicators in the front that detect the SNR value, and we do that in steps of 3 dB.
Why exactly 3 dBs? Why do we use that?
It is so that a level of 3 dB indicates that you have duplicated the signal to noise ratio between the signal and the background noise, so to say. So for each 3 dB, you have doubled the signal to noise ratio. And the levels that we indicate and detect with the LED indicators is, first, if none of them are lit, then we have less than 3 dB on this actual cable. And this cable or pair of cables is not reliable. So here you have to do test out another pair or another type of cable. The second choice then is SNR between 3 and 5. This cable will absolutely work, but we recommend to try and to improve the characteristics of that cable. So try to improve the SNR value. We call that a marginal DSN link. It will absolutely work, but there will be better possibilities if we can find a better pair. If we achieve 6 to 9 dB, that will absolutely work, and we can guarantee the connectivity. That is a normal link. If we have SNR above 9 dB, that is a high quality connection and a very strong DSL link. So that is the first possibility you have to measure the SNR value. There is, though, other options. Mikael talked about long-term test, and with our WeConfig tool, software tool for installation and also diagnostic, we can do different things, and I will show you that. Here you have, I have started WeConfig, so this is how it looks like. I have a very small installation, 5 units on my computer. The 2 units that, the highlighted units, those are SHDSL units. And in the bottom pane here, you can see more information about the connectivity between these two. For instance, you can see that they are in forwarding mode, the speed, the data rate, and here you have the SNR value as a graph. We also have the SNR value in dB as well. So this is a snapshot of how it looks like exactly now. What we also can do is to use the diagnostic feature in WeConfig and measure that continuously over time. I have now a sample rate of 1 second, so you can see what happens. And here we now measure the value of the link that I have. So you can see that it fluctuates. And this can be measured over time. We can also export this onto an CSV file for very long-term tests. So for instance, over a week. And the CSV file can then be used to analyze the result. So this is a very good complement to the tool that we have talked about in DDW 142. Yeah, Mikael, it's now your turn to talk about cybersecurity, I think.
Yeah, exactly. So cybersecurity is very important today in industrial networks. And SHDSL is not an exception to this. We need to make sure that everything is secured as much as it can. And the good thing with SHDSL is that these are more or less interfaces located on standard Ethernet switches. So we can actually use the same functions and functionality that we have in VOS, which is our operating system for our standard switch range. So we can use the firewall filtering, for instance, to make sure that we only allow the traffic that we absolutely want to onto the SHDSL links. We can also use VPNs to make sure that we have an integrity check of the SHDSL links, especially when we go between buildings or for longer distances. It's important to protect the integrity of this communication. It's very easy to set up as we have all this built into each and every device. And we also take cybersecurity very seriously here at Westermo. We have an entire section of our homepage dedicated to this subject matter. We also have a dedicated security team, task force that actually continuously scan the internet for CVEs and possible vulnerabilities on the open source packages that we use for VOS to make sure it has the highest possible standard from a cybersecurity point of view.
Good. Okay, let's then look into how to calculate distance and bandwidth. We have talked about that. Different types of cables affect the distance and speed in different ways. And there is a possibility to do that. We have a reach calculator built into WeConfig. And if I go back to WeConfig again and open up the reach calculator, it looks like this. The first thing that we can do is to pick up the right background noise for the actual installation. Let's say that it's medium noise. The second thing to do is to choose the cable that I have in my installation, and then if I add that to the reach calculator, I will have a graph showing exactly how far I can go on a certain distance. So if I look at 1 kilometer, I can see that it's possible for me to achieve 11 megabit per second in this installation. I can also compare this with another cable. Let's say that I have an option to use 0.5 millimeter cable. If I then add that, I can compare these two with each other. So looking at 2 kilometer, now I can achieve 9 megabits, still 9 megabits with this cable. So as you can see, the reach and the bandwidth will rely on the cable characteristics quite a lot when it comes to different cable characteristics. So that is the reach calculator. The second thing I would like to highlight is an SHDSL white paper that we have written, and this will be you will have a mail afterwards with a link to this white paper, so you can download it and read all about it. In this white paper, we have also a section regarding lightning protectors and other types of securities regarding connectivity between two SHDSL units. So this is very useful for installation. So I recommend you to download that after this section.
Good. Okay, so finally, what type of products do we have that we can actually provide you an alternative to fiber? So first of all, the family of SHDSL products is called the Wolverine. And the first one is the DDW120, which is it's not a completely unmanaged device, but it will allow you to read out characteristics of the SNR values and the speeds and stuff like that you will be able to achieve just using a console cable. You can see all that. But the VOS or the totally managed devices are the DDW142 and 242, which is the smallest managed SHDSL device that we have. We also have the DDW225s and 226, which also carry the VOS operating system. And some example applications that you can actually achieve with this type of technology. Bo talked earlier on the bridge application that they used to have a multi-drop modem solution, and using this SHDSL technology, it's very easy to actually replace the network or the modems and keep the end serial equipment as well, as we can also use serial over IP together with these devices. So most of these models have a serial port on them, so you can actually convert the serial communication to IP in the same device. We also have 142s and 242s, which have a bypass relay. So in the case where you have a multi-drop system and you still need to have some sort of redundancy, because normally if a device gets powered down on a multi-drop link, you will lose the rest of this bus. But with the bypass relay, we can just bypass that device and still have connectivity to the rest of the network. It is also possible to use Ethernet protocols that normally are used for normal standard Ethernet switches, so like the FRN to ring protocol that we have. You can use that to build ring topology solutions with SHDSL links as well. So these were some of the applications that you can use for this. These are just examples or hints on how you can use these devices. But I will now hand over to Magnus again to see if we have any questions received.
So thank you, Bo and Mikael. There has been a few questions, so let's see if I can just get back to the presentation here. All right. So let's see here if I can try to summarize questions. First, a quick one. Compared to fiber, for example, how reliable is SHDSL over twisted pair copper and also old copper cables?
It all depends on the kind of the background noise that you have on the cables, but when measuring it using devices, for instance, you can easily see that it will work properly. We have improved the lightning protectors or surge protectors on the interfaces themselves to withstand, as we're using long copper cables. It's it picks up noise and such things on the link, but it is very reliable. But like Bo said, and I also partly that if you have interference, it can affect the communication, but we have functions and features built into the SHDSL devices as well, like the fast reconnect, for instance. So if you have a spike on the link, then it will keep the SHDSL link online to kind of bridge that spike in the interference that comes in, so we can still keep on running after it has passed, for instance.
And if I comment on that as well, over the years, I think we have more than 50,000 units connected out there. So there's a lot of different applications running SHDSL. And the feedback from the market is that it is really reliable, and you can achieve long distance applications and also demanding applications in harsh environments. So I would actually say that it's as reliable as it can be, and you can for sure use that in any type of application.
Okay, thank you. And this might be related to this question then. How can a long copper SHDSL line be protected in terms of overcurrent?
Yeah, that is, like you said, with lightning protectors and stuff like that, that is kind of the way to do it. With external ones to keep an even higher level of protection for this. And the white paper that Bo mentioned contains basically all information that you need to have in order to order the right characteristics on these protectors.
But we have also inbuilt components to protect our units. We have gas charge tubes and fast diodes that take care of spikes as well. So we do whatever we can, but to protect us towards a lightning strike, that has to be an external equipment to do that job.
Okay. And here's a final quick one. If the line drops, do I have to restart the connected units?
It kind of depends on how fast it is, but normally no, because they will retrain the link by themselves automatically. As soon as you connect them together, they will start to negotiate to set up a link. Like I said earlier, if you connect port 1 to port 2, they will automatically start to do this negotiation and set up the link. If you have the very short disconnections, then we have the fast reconnecting, or it's not called fast reconnect, it's called
emergency freeze.
Exactly, thank you. The emergency freeze function that will actually help bridge over this gap that will actually occur, and then you don't have to retrain the link as well.
All right. And that's actually all I had coming from the audience. So again, thank you so much for presenting and sharing this with us. And I hope that everybody have got their questions answered and found this webinar useful. So we are coming to the end of the session, but before we say goodbye, I just want to mention what happens next. You will receive an email including a playback recording link if you wish to repeat anything. I will also include a download link to the white paper Bo and Mikael mentioned on SHDSL monitoring. I will also include a few links to successful customer case studies where copper cables were used instead of fiber or as a complement to a regular Ethernet network. And lastly, contact details to your local Westermo office or distributor. You can find this information on the website under the contact section as well, but I'll include that in the email. These are the people, of course, you should talk to if you have any further questions or if you want to discuss a solution or if you need a quote. Also, next Westermo webinar will be about cybersecurity in industrial application. So if this is something that interests you, make sure to check back and sign up. And with that, I wish to thank you for joining. I hope you have found this webinar useful, and good luck to you in your communication work going forward. We are here to help if you need it. So until the next time, goodbye.